Hi everyone, my name is Emad Barsoum. Please let me introduce you Greg from TensorWave. Hi Greg.
Hey Emad.
Nice to meet you. So before scaling law was only focused on training, how much compute you need to and how much data you need to reach certain loss. Now with all the talk test time compute, how do you think that impacts that and impact also the direction of scalar LLM?
So we're seeing more compute being spent on inference, as you mentioned. Part of this is taking advantage of the data that we already have. So the first generations of LLMs were trained on the internet. They're trained by crawling the common crawl, all of the websites, all of the posts that are available on the internet, and to predict the next token. So there's some signal, there's some learnings that the LLM can take from that huge body of tokens on the internet. But as we're trying to push these models so that they're even more accurate, we're finding that there are just more effective ways of training them. So instead of just training on the raw tokens, we found that reasoning over the tokens, thinking through what questions could be asked, what is the right way of getting to the answer. Devoting more time to inference actually leads to better training data. So where the training data in this case is not just the raw tokens, but it's the question, the token context information, and a reasoning trajectory. So those tokens in the reasoning trajectory are generated by the inference engine. And that's why we need both.
Does ScalarLM have any, it's great to integrate both training and inference. Does it have also any logic to this for reasoning model?
Does it have logic for reasoning? So we actually think of the reasoning layer as being built on top of ScalarLM.
Okay.
It's a fairly simple loop. So we found like two key primitives. One is well known, one is just inference. People are probably familiar with the OpenAI client, the completions client. That's just a way of asking the model, given a context, answer a question or complete the sentence. So that's a common API. We've also found that there's a similar API for training, which is taking a body of training data and then producing a model. So with those two primitives, you can effectively write a loop that will first use inference to generate the reasoning trajectories, say, reason through this question to answer it. That generates reasoning data, and then that can feed directly into the training operation.
Okay. And most training model with reasoning model, part of also that connect both is using RL. Is that something you have in mind for future scalar LLM, or do you see that as layer on the top of scalar LLM?
Yeah, we think of it as a layer that's on top, but we do plan. One of the community projects that I think is really helpful in doing this is the Llama stack from Meta, which has reference implementations of inference, of memory, of agents, of evaluations. So we think that the methods that are used to build evaluation functions and reward functions are great for use in reinforcement learning. In reinforcement learning, we effectively have a reward model, which is very similar to the building blocks we found that we use for evaluations.
Okay. How do you compare ScalarLM and other open source solution versus proprietary solution? And what do you think the direction will go eventually?
Sure. I personally think that the future is open. I think we're seeing the first generation of inference engines for LLMs was typically proprietary, but these days, I think with frameworks like SGLang and VLM, we're seeing just very high performance and very modern with full features open source projects. So our belief is that just like in machine learning frameworks, we eventually consolidated on PyTorch, which was an open source community-driven framework, of course led by amazing developers at Meta. We think that there's going to be a similar evolution of these additional higher level layers that are built on top of PyTorch and that are built on top of the LLM inference and training engines.
Okay. And for let's go a little deeper on scalar LLM. Can you describe the architecture, how you glue together the training plus the inference part inside a single umbrella?
Yeah, absolutely. I think one of the very difficult things to get right is the infrastructure management. So being able to deploy this, of course, you're going to want to deploy it on a lot of GPUs. So you need some framework to orchestrate and manage that cluster of GPUs. We also are heavily influenced by containers. We think that modern software is typically developed on containers outside of HPC. Even maybe HPC is coming around, but we think that the underlying layer that manages the orchestration needs to be containerized. And we found that the best open solution for that we found so far is Kubernetes. Okay. So we actually do something interesting there though, because in order to do training, Kubernetes doesn't have a SPIMD model that has barriers. It has this kind of more dynamic work allocation where it kind of has replica sets that it auto-scales. And that's really different than the way that frameworks like Slurm or that most high-performance training stacks will work, because they'd assume reduction operations, collective operations, and barriers. So we actually run an overlay of Slurm, which provides the MPI environment and provides that SPIMD layer on top of a set of containers that are deployed on Kubernetes. So it kind of manages the best of both worlds. Yeah. I personally think in the future there's going to be some unification of those layers or some redesign of those layers. It seems strange that there's two separate frameworks, but we really need one piece, the containers from Kubernetes and the SPIMD model from Slurm in order to build ScalarLM today.
And you for training you use Megatron, and for inference VLLM, is that correct?
Yes.
Why you chose both VLLM and Megatron, and are you planning to add more framework in both side inference and training?
Yeah, that's a great question. I think our belief is that the interfaces around the inference engine and the training engine, I think we can standardize and solidify those over time, but we see rapid evolution in both of the frameworks. Yeah. So, compared to maybe a year ago, the inference frameworks were completely different. Like VLM was a research project, that had like very basic support and no performance optimization. Within a year, it's gotten, much better feature support, model support, much better performance. We see the same thing. I actually think the training side is less mature. Like there's just, there's only a few organizations in the world who are doing training. It's just a much smaller community. So we see there's more evolution in inference faster than in training, but we think they're going to catch up. I think both of these are important ingredients. I don't think LLMs are going away anytime soon. So I think as the community grows, both of those pieces are going to get, whether it's the same framework, whether we swap it for a new framework, they're going to change significantly.